So I'm really honored and excited to welcome Matt Grob to our stage. Matt is the CTO and Executive Vice President of Qualcomm Technologies. He oversees all of Qualcomm's technology paths, coordinates the R&D activities across the entire company. Another, technologist at heart, has a Master's of Science in Electrical Engineering from Stanford and a Bachelor of Science in Electrical Engineering from Bradley University. He's, one of the things that we always think about at CloudFlare is that when we're doing our job right, people don't even know that we exist. And every single person in this room is using is using Qualcomm's technology today. And so Matt, I'd love you just to, I don't know that everyone knows what Qualcomm does, so can you just tell us a little bit about what it is?
Sure. Okay. Thanks a lot. It's great to be here. So what do we do at Qualcomm? It's a good question. We do digital wireless communication, mobile internet. We basically make the chips that are in most of the smartphones of the world. So most of you have a smartphone with one of our chips in it. We started off, and it's still our core business, basically finding ways to push as much information as possible over a minimum amount of radio spectrum at the lowest possible power. And that's our core modem business, and now we've since added multimedia graphics, cameras, and position location, and all kinds of stuff. But our core business is to make the mobile internet move as fast and efficiently as possible.
So I don't know if people in the audience know, but this mobile thing might be kind of a big deal.
It might be.
If you were playing a drinking game with our earlier panelists and you did a shot every time someone said the word mobile, you'd be passed out in a bathroom somewhere at this point. And so, what I'd love to hear about, what about the internet? What's challenging about mobile on the internet, and what is Qualcomm doing to help, build a more mobile internet?
Okay, great. So let's to understand what's challenging, I'm going to just rattle off a few numbers. When digital cellular started, say maybe 20 years ago or 25 years ago, we were using a cell phone to do a voice call that had an 8 kilobit per second speech coder at the peak rate, and the average maybe half of that. So you had about 4 kilobits per second that you were using this device for. And now, what do you want with your phone? Do you want a megabit? No. Do you want 10 megabits? No. You really want hundreds of megabits or even gigabits. So you want a phone that moves as much traffic as 100,000 phones used to move. And you want 100,000x, and you would like it to last all day and all night, and you would like it to be thin and small without having to pull the aerial or antenna up. You would like it to have cameras, and you would also like it to move around and all of those things. So that is the challenge, moving all that data, processing it, having in a network to be able to support that. It needs to be up close to you in many cases, so it's fast. It needs to be secure. Those are the challenges.
And so, it seems like with LTE, which, Qualcomm was the pioneer behind, and I often will switch off Wi-Fi just to be able to use the LTE network on my phone because it's as fast as it is. Is that, how much faster can we actually make mobile phones going forward? Is this as good as it gets, or how much headroom is there?
Well, that's the good news. It's not as good as it gets. It's going to get a lot better. It's actually going to get dramatically better. So there's LTE, which is a cellular technology, and you also know it maybe as 4G, and it's what AT&T, Verizon, Sprint, T-Mobile, and others offer on licensed spectrum. And then there's the unlicensed technologies, 802.11 family Wi-Fi. That's what's on the back of your badge here. You can log in. Both of those are going to get dramatically better. We're going to be able to increase by orders of magnitude. In fact, we kind of target 1,000-fold in 10 years from the performance that we have today, which basically means we need to have technology that doubles the performance every year.
But and is that, how much is that how much of that do you still have to develop versus are these technologies that are in the pipe, and it's just, it takes a long time for mobile networks to upgrade. Do you know that that's going to happen, or do you think that that's going to happen?
Well, We believe it will happen. Okay. So what does it take to make that happen? It's really a number of factors. One is we're going to try and make the modems better. And we're still doing that, but really we're not going to make the modems for a given amount of spectrum and power 100,000 times or 1,000 times better. They're going to be made, maybe 10 times better. We also need to bring more spectrum to bear on the problem and be able to reuse that spectrum more often. So that means that the cells need to shrink and have a smaller radius. And that's where it gets into different network architectures. And you need to have, if you're going to have a gigabit phone and you want instant content, you're probably not going to be able to pull that halfway around the globe every time you want it. It's going to need to be close to you, even when you're mobile. And it's going to need to be secure and low power because you're going to have a large number of small base stations. That's the kind of paradigm we're looking at.
So one of the things we were talking about upstairs is that you think that maybe even moving away from a cell-based architecture to a topology that would be more peer-to-peer based. Can you tell us more about that and how that's how Qualcomm is thinking about that?
Sure. So, the paradigm that we've had for a long time in cellular is that there's a tower outside and there's a phone and you make a phone call and it's phone to base station. Those paradigms, of course, are still useful for outdoor and wide area, but there's a lot of new paradigms, such as indoor to indoor, indoor to outdoor, and then phone to phone, not just necessarily phone to base station. So the ability for my phone to communicate directly with, say, everyone in the room here. You're close to me. If I want to send you a bunch of slides, for example, or a video, I don't need to go a long ways away and then come back. I can do it in here. So peer-to-peer is important. Multicast is important. If you wanted to watch, let's say you're an operator and you wanted to offer instant replay at a sports venue, well, you don't want to transmit the same data to every user on a unique channel because that will load up the network. You want to do that in multicast. But when the game's over, you want to recover that spectrum back to unicast. So the ability to change topologies, not just phone to base station, but base station to mini phones, phones to phones, those are all part of the evolution of this technology.
Can you talk more about sort of the licensed versus unlicensed spectrum? I mean, it seems like, we have, because of the way that licensed spectrum is handed out to a relatively limited number of players, that's controlled by the AT&Ts and Verizons in this country. And there's a whole bunch. I mean, we're running a wireless network right now.
Correct.
That you're using. How does that change over time? Do you think that it moves more towards a more licensed model, or are we going to start to find recovered space and white space that we can use in that unlicensed spectrum more broadly?
Right. So there's going to definitely be the spectrum is very, very precious, very valuable resource. So there's always a place for licensed spectrum. The big operators are going to own spectrum, and when they own it, they can decide which technology is used on it. They can clear it just for that vintage of technology and get the best possible performance. But along with that is unlicensed spectrum. So like you said, in this room, many of you are probably deciding whether you're going to use the cellular or you're going to use the free Wi-Fi. And that's an interesting choice that you're going to make because on one side you got your data plan and you might have a cap on that. On the other side, it might be free, but depending on how many people are using it, it might not be as high performance. Maybe other times it's higher performance. So you have this kind of choice you make. But in the future, the phone is going to be a lot smarter. And your wireless provider will be able to use both types of spectrum. And your venue, your host, will also be able to offer cellular type technologies from the LTE family in the unlicensed band. That's something we're working a lot on right now. And by the way, when I mention that, we're taking great care that we do the coexistence so that all of these can peacefully work together without creating undue interference. And it's going to provide, actually it's good news for all the users because it's going to give you more choices and better performance.
So what is Qualcomm's role? I mean, you've got the mobile phone vendors, whether it's Apple or Samsung. You've got the carriers. You've got the base station owners and operators, and you end up touching all of those different players. How do you think about product development inside Qualcomm when you have essentially so many different customers that are there. Are you going to the operators and saying, hey, you should do it this way, or the operators coming to you, or what's that? How does that work?
So, well, we definitely go to the operators and say, here's some options for you that we think are worth considering. They ultimately make the big decisions on what type of technology. But to give you an idea, to answer your question on how we think about this, a modern cellular modem has literally 1,000 features in it. And I'm not kidding. You look at a spreadsheet, and then you count how many features are individual, commercially tested against a network, and you count them, there are 1,000. And that, by the way, that number is not getting any smaller. So in order to keep innovating on this technology, you really have to influence both sides of the link. You have to work with the infrastructure vendors, which we always have, and in some cases supply them some ASICs. In other cases, we work with them in the standards process. And you have to work with on the phone side so that these 1,000 features come out, more or less together and can interoperate.
And is that? I mean, that's got to be. What's the time to market of a new feature? I mean, you have to coordinate across all these things. I assume that the product pipeline, it's got to be years, or.
It's years, but you know what? It's actually getting faster, and this is one thing after watching at Qualcomm for many years that I started to become more of a believer in the singularity that's coming, because it's getting faster and faster. If you look at how much time it used to take to design a chip of a certain size, get it back from tape out, and then get it running in the lab, that has shrunk dramatically in spite of the fact that complexity is dramatically higher. And then at a more macro level, the amount of time a new vintage of cellular, from the time the standards is published and the ink is dry to the time, say, 100 cities have deployed it, that's also gone down. 4G was dramatically faster than 3G was in that regard. And now we're working on 5G, and already the operators are moving the schedule to the left. So it does take years. There's a big investment involved, but it's actually getting faster and faster.
So you travel a bunch, I travel a bunch, and I'm surprised, in places like San Francisco and New York, where 5 years ago the cell phone data service was terrible, and how much that's improved over the last little bit. But then on other times, I travel through Europe, and in London, downtown London, you still can't get LTE service in downtown London, or you're back on sometimes an old edge network on your phone. What regions, how is that? I know you don't want to pick favorite carriers, but what regions are really if you're traveling there and should you think, wow, these guys, this is really state of the art. Who's pushing the bounds of cellular technology today?
Well, traditionally, a lot of new capabilities in cellular would start in Korea first. LTE was very prominent in the US first. And Verizon in particular, they've been very public and vocal about their support for 5G. They're pushing very hard. But now, of course, China is really, really an amazing marketplace for all of this. Perhaps in the past, the regulator took some time to give out the licenses. And once that happened, it really, really took off. In Europe and elsewhere, we're finding that once an operator gets spectrum for 4G, then their new work on 3G quickly goes down, and the 4G goes on really fast. So spectrum policy is a big enabler for how fast a given region will deploy. Typically, once they get the spectrum, they go really fast.
And I assume that it just enters another party to all of this, which is the regulators that are setting what that policy is. Do you work closely with those, the FCCs in the U.S. or China or Europe for
all of them,
that?
Yes. We work closely with all the regulators, FCC, Ofcom in China, and that's a really important aspect to our business actually, and the operators is to constantly lobby for more of radio spectrum to be used for mobile services, which is the service that provides the most economic benefit to the region.
Yeah. One of the things that we think about a lot are when that there are a relatively few number of providers that are providing the last mile connectivity to sort of the eyeball networks. And what we've seen with network neutrality and otherwise is a real big push. And internally, it sort of seems like that the solution at some level is going to be technological, and we're not going to trench more cables in the street. And so wireless has to be some piece of that. How are you guys thinking about that? And I know you've got sort of customers who are traditional wireline carriers and everyone in between. Is that like, am I someday going to be able to cut my cord entirely with Comcast and just use a wireless provider for my home internet access?
So the wireless operators want that scenario to come to pass, and it probably will be possible. Meanwhile, cable operators such as Comcast want to be able to grow the footprint of their unlicensed spectrum networks so that you perhaps can just use their services for most of your mobility needs too. Maybe you occasionally hand off, but for most of it. So both of those things are happening. On the wireless operator side, we're doing work on the last mile. You've heard that term for years. The last 100 meters. We're doing research on how to make use of millimeter wave and above 6 gigahertz bands, including in new ways that had not been considered in the past, which is to use those bands for outdoor use, and in some cases even to some degree penetrate building structures so you can have indoor coverage. And that will allow a traditional wireless operator to offer high-speed services in the home. Meanwhile, we're doing things like what we call multifier, which is a version of LTE that runs entirely in an unlicensed spectrum that can give a cable operator a cellular-like kind of capability without the need to own spectrum. So I think both of those are going to happen, and those are technology things. Whether or not you cut the cord also has to do with, does your provider have access to content, programming, NFL, what have you. That's also a big factor.
So this is a very technical audience. Talk a little bit about what's hard about why when there's a Giants game do I have a harder time getting reception, and what is it about Qualcomm's technology that makes that work? And so where technically do we get the improvements if we're really going to have 1,000x faster mobile data? How's that going to work?
Okay, so picture the following. Let's say it's like mid-1990s, and you want to put up a base station, and you want to provide cellular service. So you put a tower up on an antenna up on a tower on a building, and you pick, say, 800 megahertz of spectrum at that band, a couple megahertz wide, and you're happy because that'll go 30 kilometers. And this thing will go 30 kilometers, and it'll pick up any cell phone inside 30 kilometers. And you think, wow, that's great. I can provide coverage. But today, if you did that, if you really had a base station that went 30 kilometers, it would pick up 100,000 smartphones all trying to do, 4K video at the same time. By the way, not just receiving 4K video, but authoring and sending it too. So now you don't want large coverage. You want actually small coverage. You want to be able to reuse that spectrum and have many, many base stations. So that, to answer your question, is one of the technology challenges. How do you reuse the spectrum much more often? How do you allow handoffs, which they're going to be many more boundaries and they're going to be more fluid? You're going to have to provide backhaul to more stations, and you're going to have to put cache memory and security. And there's so many of them that they're going to fail more often, so you want overlapping. How are you going to manage all that? Those are some of the challenges.
And does Qualcomm, for an operator that's building one of those networks, are you when you sell that to an AT&T or someone, are you kind of the complete solution for that, or are you how does that
We're
work?
not. So we supply the ASICs that go on the phone, to some extent the ASICs that go on the base station. We do supply network services where we'll go and we'll run a lot of very detailed tests, and we can provide the operator with assessment and reports. But in terms of a one-stop shop, that's more the role of the infrastructure vendor.
Yep.
So they will deploy, they'll put the base stations, run the backhauls, and operate the network. So some operators rely heavily on their vendors. Some of them do a little bit more of it on their own. Our role is a little bit less in that regard.
So, as as new fun markets emerge, like we have a bunch of our engineers have drones that they're flying around, and I mean it's amazing that you know, a drone today is really just a mobile phone at some level. How are you thinking about sort of technologies like drones or other things? Does Qualcomm have a role to play?
Yes, I'm so glad you asked that, because I just love what's happening with the drones. So, you know, the drones, in particular the consumer personal drones that you see all the time now, which, by the way, is actually getting to be a reasonably sized market and almost didn't exist a few years ago. Compare that thing to a smartphone. Okay, so it wants to be connected. Drone connected, smartphone connected. It wants to have position location, same. It wants to have a camera and media features, same. It wants to have sensors and gyros, same. It wants to be low power, have high computing power, all that stuff. It's really very much the same. So, but the drones are pushing this field in interesting ways. For example, all the drone vendors want 4K video. They want 4K video encode, but they want simultaneous 720p streaming, so that when you're flying around, you can watch in real time while it's capturing 4K. That's an interesting challenge. That's pushing us in a certain way. They want 10 hertz GPS. A regular smartphone does maybe 1/10 of a hertz GPS, because that's not good enough for mapping and whatnot. It's not good enough for real-time control. They all want that. They want computer vision to help with obstacle avoidance and range detection and landing and takeoff and all that stuff. Well, guess what? Autonomous vehicles want those same things too, except the drones are actually evolving faster. They just, you know, vendors are putting out 2 or 3 products per year. So that's actually really going in an interesting direction. These are mobile devices. When we look forward to 5G with ultra reliability and extreme security networks and different regulatory paradigms for airspace, we kind of feel that the combination of these very capable, low-cost, highly reliable systems with highly reliable networks and security might really unlock some new use cases.
Is that an initiative within Qualcomm? Are you specifically thinking about drones and robotics as a subset within Qualcomm, or is it sort of dovetailing off of phones?
Well, it's part of what we call the umbrella term IoT or IoE. So within there, these are things. They're not phones, but these are sort of the high end. I mean, you can think of Internet of Things as being a temperature sensor in your house or something like that. That's great, by the way. We've fully supported it, but these are very low-end devices. Whereas a drone or a robotic device, or even some of the internet-connected cameras, they're much higher end, very sophisticated. They have computer vision, machine learning algorithms that run inside. They have cloud connections. They have position location. They may move around. So that's the kind of IoT that we absolutely are interested in. That we just, not to do marketing, but we've announced some variants in the space recently, and have some customers now. So it's pretty exciting.
One of my favorite conversations we had, which was right after we started working together, was in Switzerland, and you were telling me about what Qualcomm is doing in order to launch satellites to provide internet service globally. We don't have a ton of time left, but I'd love you to kind of give a preview of what's coming on that and how you guys are thinking about that initiative.
Okay, we're a partner, a major partner in the initiative known as OneWeb, and it is a new satellite-based system of unprecedented specification. Actually, pretty exciting. It will feature over 648 low Earth orbit satellites. So they're low Earth orbit. They're a few hundred miles away instead of thousands of miles away. And the reason that's important is it allows the antennas to be smaller. It also dramatically reduces the latency. So if you want to do gaming or real-time interactive services, you get a very good experience. The coverage will be global. It will work on vehicles, aircraft, boats, planes, cars, trains. The real target for this is emerging markets. It's not necessary in a dense area here. There might be special applications like emergency response or public safety. In the US, there's actually about 1.5 million residential users that use satellite services. They're not in the cities, they're out and about, but there's a lot of them. They generally would like to have a system with lower latency. So, and that's just the US, there's the world. And so we're working on that, and 600 satellites will be a new record. By the way, the terminal of that system is not the phone, it's a small base station, so it does like the reuse that I was telling you earlier. And then you just use regular devices, regular Wi-Fi and cellular both, regular phones, tablets, whatever, and you'll be able to get internet everywhere on the planet at a much lower cost. I mean, you can do that today with some satellite modems, but this will be at a much, much lower cost.
That's really, I mean, when I was listening to David Brin speak earlier, thinking about, you know, the policy challenges around something like that, because these satellites are literally crossing national boundaries, but if you can make that work, that really does have an opportunity to be very disruptive to a lot of the industry,
Right.
You know, it's pretty interesting work that you're doing there. Do you think in 5 years' time it will be anachronistic to call Qualcomm a mobile telephone company or a mobile phone company?
Certainly a mobile telephone company. Yeah. We call it mobile. You know, we're really moving into what we call mobile computing.
Yeah.
So the modern product we make, which used to be, actually at the very beginning, it was multiple chips that together made a single modem. And now it's one chip that has, you know, a dozen modems on one corner of it, along with GPU, multiple CPUs, multi-core, sensors, and all this other stuff. So we refer to that whole product as really a mobile computer. And yeah, we won't be known as much as a phone company. You know, long ago, we actually did make phones. I don't know if any of you guys ever saw or remember, but we had something called the Q phone. It was a clamshell phone, and during that time is when we got the naming rights of the stadium in San Diego, which is still called Qualcomm Stadium. But those days are behind us now, and we're really into mobile computing.
You know, one of the things that we're really excited is that with CloudFlare we have to deploy a lot of servers around the world, and we can't necessarily go into the most power efficient places always, and so we spend just a bunch on power. And so, you know, talking with your team and some of the ways that you're thinking about the server market, and really at a minimum keeping Intel honest, and hopefully allowing us to get more cores per watt effectively, that we can deploy our service, is something that, you know, we're super excited about, and is really an amazing initiative. We have time for about 1 or 2 questions quickly. Does anyone have a question? Lauren's got the mic.
My name is Jason. I'm with a seed investment firm in San Francisco and Beijing. Also a formal advisor to the State Department for spectrum allocation for 5G between China and the United States. So just wanted to ask you, within your boundaries of corporate communications, could you just pontificate with what you think about 5G or what Qualcomm's thinking about 5G?
Sure, I'd love to talk about 5G all day.
I thought you were going to go a different direction with that question, which would have maybe been a more sensitive area, but.
So, you know, what we want to do with 5G, 4G, when you compare 4G to 3G, how do you think of it? Well, you think of it as it's the same stuff, but it's faster. It's faster because it's wider bands and there's more spectrum. So when you think about 5G, we don't want you to think that it's just faster. It is going to be faster, okay, cool. But it's going to be more than just faster. It's going to be faster. It's also going to have lower latency. It's going to have higher reliability, so you can do things like control vehicles, including drones and airborne vehicles, or medical devices, medical procedures. I'm not talking just about a fitness band, that's great, but I'm talking about a kind of medical procedure where the physician is on one side of the radio and the patient's on the other, and you need to have that thing be rock solid. So we're envisioning 5G is going to enable not just higher performance, yes, we're going to have that, but also a whole bunch of new services that are not possible today, and we're designing that in. And that's because when you think of 4G, the physical layer and the radio for that was designed you know, back around 2003, 4, before the iPhone, before all that. And now we're involving a lot more. We're involving the automobile vendors, the robotics vendors, medical devices. We're getting all those requirements in at the very beginning, so we're going to have a much more capable result.
Terrific. Thank you so much, Matt. It's a real, it's a real pleasure at CloudFlare to be working with the team at Qualcomm and how great it is. And as we joke internally, we're going to lobby pretty hard to put CloudFlare software on those satellites so we can have our first pops in space. So
let's do it.
Appreciate it. Yeah. Thank
All
you.
right.
Thank you.
Thank
very
you.
much.